All right, now our last video of the chapter here, we have a problem. It says the time it takes for a technician required to perform preventive maintenance on an air conditioning unit is governed by an exponential distribution whose density curve appears to the right. The mean time is 1, and the standard deviation is also 1. Your company wants a contract for 70 air conditioners. What's the probability that your average is 1.1 hours per air conditioner? All right, to do this, we look at this and we say the probability that my X bar, what's the probability that you average 1.1 hours or less than or equal to 1.1. Now, there's some things we have to check out first. First off, we have to see if we can use a normal distribution. So here we have 70. 70 is greater than 30. So what we can do is we can just say central limit theorem tells us uh, sampling distribution is approximately normal. So now we have that. Now we know it's normal. Now we have to figure out if we can use our standard deviation. Now we can use our standard deviation if our population is at least 10 times as big as our sample. So our sample is 70. So are there more than 700 air conditioners? Yes. You can just say there are more than 700 air conditioners. All right, so now we can use our standard deviation. We know we can use a normal distribution. So now we can just come over here and work our way through this. So our z is less than 1.1 minus the mean for this, which is 1, over our standard deviation, which is 1, over the square root of n, which is 70. Since this is an x-bar distribution, we have to use this standard deviation. So that's the probability my z-score is less than or equal to so 1 over the square root of 70 is 0.111. So 0.1 divided by that, I got a z-score of 0.8366. So a normal CDF from negative infinity up until that number will get us a probability of 0.7986. So about 80% of the time, we'll get a value that's less than 1.1. Now it says how many hours should you budget if you want to have a probability of 99% for an average time of 70 air conditioners. So I want to make sure we're able to do it 99% of the time. So we're saying that this is 0.99. We want to find that value down there. Well, if our sampling distribution has a mean of 1, a standard deviation of x bar is 1 over the square root of 70, then we're going to do an inverse norm to figure this out. Our z-score is equal to x minus mean over standard deviation, the square root of n. Now at 99th percentile, if I do inverse norm of 0.99, I get the value of 2.326. The x value is what we're looking for. Our mean is 1, and our standard deviation is 1 over the square root of 70, which is 0.1195, actually. So now we take this number and multiply it by 2.326, and then add 1 to it. And so our x value is 1.278. So that's the value, 1.278. That's how many hours that you'd need to budget to make sure that you would be able to get 99% of the things done in time.